Hello, welcome to this video and this video series. I'm Terry VanNoy. Understanding significant digits. Now in this video we are going to be continuing on about what are the rules about what makes a digit in a number significant or not. And we're going to focus on zeros in this lesson. Now, why do you have to learn significant digits? My example from the previous video is to help you determine how precisely to express your answers when you're doing a calculation. And it has to do with how do you know what to round your answer to? How many places? Well, it has to do with the number of significant digits used in your calculation. I'll give you some examples a little further into this video series. But right now, let's go over rules 2, 3, and 4 for zeros. Alright, you already know that non-zero digits in a number are significant, and that's the easiest rule of all. Anything that's not a zero is a significant digit. Now, rule 2 is the first rule about zeros, and it has to do with leading zeros. Leading zeros are not significant. Now, what's a leading zero? As you might suspect, it has to do with being on the left side of the number. So these zeros here are in front of the 4. 4 is a significant digit, of course, so it's anything that's sort of hanging out on the left-hand side. Okay, we call it at the beginning of the number, the left side. Now, normally we don't write 374 as 00374, but again, I want to make the point that it's to the left of the last significant digit here in this number, which is the 3. So in this case, those zeros are not significant. They are leading zeros. They're never significant. That means we can cross these out and realize this is a one significant figure number. This is a 4. This has 4 significant digits because we don't count these two leading zeros. All right, simple as that. Rule 3, embedded zeros are always significant. Embedded zeros. All right, where are they in these numbers? Well, an embedded zero is any zero that's in between any significant digits. So this 0 here is embedded. It's between the 3 and the 6, of course. This one is embedded. This one, these two, of course, and this one here. All right, they are significant. So in the first number, 30,642, that contains 5 significant digits, including that 0. All right, this has 3 significant digits. That is an embedded 0 right there. And this has, yes, you guessed it, 8. All right, all of those digits are significant. Okay, that's a lot. Now, what about this one? This is a leading 0, isn't it? Okay, it is on the left-hand side of the number. That does not count. So that's why that has 3 significant digits. And the last rule, rule 4, trailing zeros in a number might be significant. Now, it doesn't sound like much of a rule, but here's the key. Is there a decimal point? All right, that's the key. Is there a decimal point in the number? All right, first of all, in this number, 152,000, those are at the end of the number. There is no decimal point. All right, that means that those trailing zeros don't count. This number has 3 significant digits. This number, 159,600, does have a decimal point. All right, because it has a decimal point, we have to assume that something was measured to that exact unit place right there. Okay, so we do count those zeros and, of course, all these other digits. So we're going to have 6 significant digits in that number because of the decimal point on the trailing zeros. Now here we have some embedded zeros, so those are going to count. There is a decimal point. And notice that everything to the right does count. So think about it. If this number was measured to the nearest hundredth, then it would be 0.06. They would not have a 0 here, but because there is a 0 there, and it's on the right-hand side of the decimal, that means we have to assume that it was measured that accurately to the thousandths place. So we do count that 0. So even though it's on the end on the right hand side, there is a decimal point, which means that we count it. So that number has 6 significant digits. All right, now the next video is where we get into the calculations. What happens if you're adding and subtracting? What happens if you're multiplying and dividing? All right, stick with me, watch the next video, and I'll see you there.